Okay, we're in section 3.3, proving lines parallel. So we're going to prove that lines are parallel this time. Now I'm going to go kind of quickly because this is pretty similar to the last section. So please feel free to pause along the way. Okay, just as a quick review, if we have two coplanar lines, here's a coplanar line and another. These two lines are coplanar, and I've got a third line cutting through both of those, intersecting both of those lines. That line is called a transversal, and it makes up all of these angles. It makes up these angles. And we know different things about these angles, or at least we know what to call these angles. We know, for example, 3 and 6, those are alternate interior angles. And we know that 3 and 5, those are same side interior angles. And we know that, for example, 1 and 6, those are corresponding angles. Or 4 and 8, those are corresponding angles. Okay, and last section, we were told that the two lines are parallel. So if the two lines that are being cut are parallel, then we know some things about the angles. We started with the corresponding angles being congruent. Okay, so we're going to do basically what we did yesterday, but the converse of those statements. So for example, this first one says, the postulate that we start out with says that if two lines, okay, any two lines, they're not parallel yet, but if these two lines are cut by a transversal, so it's being cut by a transversal, and corresponding angles are congruent, okay, so if the corresponding angles are congruent, then we can conclude that the lines are parallel. Okay, so this time we're starting out, we don't know if the lines are parallel, and then this transversal comes along, the corresponding angles, we find out they are congruent, so now we can conclude parallel lines. Okay, so let's keep going. Again, if you've got these two lines and they're being cut by a transversal, if you see, or if you find out that the alternate interior angles are congruent, then you've got parallel lines. Okay, so hopefully you're kind of seeing how this is just like the last section, but the converse of those statements. Last time we were saying that if the alternate interior, last time we said if the lines are parallel, then the alternate interior angles are congruent. This time we're saying if the alternate interior angles are congruent, then the lines are parallel. So this is a way to prove that we have parallel lines. Finding or showing that we have alternate interior angles that are congruent will prove that we have parallel lines. And again, starting with two regular lines, if you see that the same side interior angles are supplementary, then you've got parallel lines. Sorry about that little blip there. Okay, and then finally here's the one with the perpendicular lines. And this is kind of shortened up here a little bit, but it says that two perpendicular lines to this same line. So if these two lines, lines J and K, if they're perpendicular to that transversal, to the same line, then the lines are parallel. Then lines J and K are parallel. So if we were to turn this into an if-then statement, I would say if two lines are perpendicular to the same line, then the lines are parallel. All right. Now this is a little different. Through a point outside a line. Okay, so I've got my line started. Through a point outside the line, there's my point outside the line. There is exactly one line parallel to the given line. Okay, so through this point, I can only draw one line that is parallel to that given line. Now, I did not do a good job here. That is about it. Okay, so if I rotate that just right, that's pretty close. That's the only line that I can draw that's going to be parallel to the original line and goes through that point. I can take that line, I can move it up and down. It's still parallel, right? It's pretty close. It's still parallel, but it doesn't go through that line. Right now, it's going through that line. I can rotate this so it's going through the line, or I'm sorry, going through the point, but it's not parallel. There's only that one line. Okay. And related very closely to that, here it says that through a point outside a given line, there's exactly one line perpendicular to the given line. So that's pretty close. That's the only line that I can draw. There's exactly one. Now, not at least one, not more than one. There's exactly one line that goes through that point and is perpendicular to the line. Okay, last theorem here. This theorem says that two lines parallel to a third line are parallel to each other. Okay, so here's what I've got to set this up for you guys. I got a line here that I can clone. So I'm going to pull lines off here and hopefully, maybe, there it goes. So I'm cloning this line. So it's coming off, it's an exact duplicate. So I know, because it's an exact duplicate, I know that this line is parallel to this line. Okay, so let's call this line A, let's call this line B. And now I'm going to pull off another, if I can, here we go, another exact replica. So I know that this line is parallel to line A. So I know that, let's call this line C. Line C is parallel to line A. So if line B is parallel to line A and line C is parallel to line A, then those two lines, C and B, are also parallel. All right. So that is it for today. Again, please feel free to rewind, go back, or pause, and I hope you have a great day.